Hello everybody, Tom here. So in this video I would like to talk about how I created a prototype of a gameplay of my first mobile game, Inflated Pufferfish, which is heavily inspired by Flappy Bird, a second game of 20 games challenge that I am part of. Here is how it went. I started my work by doing a lot with just 2 simple clicks. What I mean by that? I copy-pasted most of the reusable components from my previous project. Some utilities for working with randoms, collisions, and what is most important, the event bus, which will be useful down the line. Then I decided to start easily with adding some background. Nothing fancy, had some gradient colors from one of my previous projects, and adding a placeholder texture for a player, this beautiful white circle. Okay, so now I had to make him move. First I added 2 actions, with a left mouse click to inflate, and a spacebar to block enemies. Touchscreen controller will be added in the future. As you probably remember from my previous video, I decided to modify a little of the behavior of our player avatar than it is in original Flappy Bird. I decided to accelerate the player's avatar up while pressing a button, and then moving down when nothing is pressed. Additionally, I wanted the player to be able to block enemies coming for him in the future. And as you can see, that's a lot of going on with this avatar. So to not make a spaghetti code for a player movement and probable animation changes and everything I will do in the future, I decided to implement a state machine for the player. There are plenty of different implementations of this, but I decided to use one from my favorite YouTuber, Git Amend. I left a link to a really detailed explanation of how it works in the description of this video right below the subscribe button. Here I will just show you a high-level idea of it. In this implementation you can find 5 main pillars: a state machine, state, transition sequencer, state driver, and state context. State context is just a class containing multiple fields with necessary data passed between states. This data is set in the next pillar, state driver. This class is a brain which coordinates the entire process and is the only one which is inheriting from the node class. Here we are instantiating a state machine, processing user input, filling the necessary data in context, and we are triggering the update method in the state machine. State machine is the heart of this implementation. It is responsible for triggering the transition sequencer, which I did not implement fully yet, because as for now I didn't see a need for that, and triggering the update method of the states. The state class is a muscle of the entire state machine. Here we are keeping the information about the parent and child state, getting the next state if data in the player context suggests so, and executing a code to update what is going on the screen. For my prototype I created a handful of states already. The first one is player root. It is mostly a technical state that the entire state machine uses as an entry point. Then there is one of the following: idle, blocking, or lost. Lost state is triggered when the player hits an obstacle or enemy. Idle state is triggered when the player is moving on the screen and is not currently blocking an attack. Blocking is triggered when the player is, well, clicking a button to block an enemy. Then we have 4 substates, and each of them can be a child of either blocking or idle state. Those substates are inflating, inflated, deflating, and deflated. Inflating state occurs when the player is accelerating up. Inflated when gained maximum speed in the up direction. Deflating when the player is accelerating down. And deflated when gained maximum speed in the down direction. Okay, so we have a player moving now. Over-engineering? Never heard of that. And of course, after finishing this state machine, I thought, okay, that was quite a lot of work. It would be a real shame if I wouldn't save this. And in that moment I figured out I didn't create a repo yet. One day, I'm sure I will regret not doing it as a first step. So, the main game loop is all about avoiding obstacles. Then, the next step is to introduce some. As a sprite, I used my player from the Pong game I made earlier, and made this obstacle move. Now I had to spawn a lot of those obstacles at a runtime. To do that I created an obstacle spawner with pooling. Yes, I know that spawning and destroying the amount of obstacles I need is not resource heavy, but it's better to learn good practice as early as possible. Now, having the obstacles spawning and moving, I decided to add plankton. Wanting it to spawn mostly in between obstacles, I had to somehow synchronize the spawners. So I took the responsibility of deciding when and where to spawn an obstacle from the spawner and created a new class, Spawn Coordinator. It calculates the spawning points of obstacles and plankton, and publishes events with information where to spawn respective objects. Because now I have multiple spawners using pooling, I decided to make a generic class for pools, to have only one mechanism for that. The next step I took was adding the functionality that would count how much plankton the player ate. After that, I made a game over screen when the player hit the obstacle. Then it was time to start working on my second new mechanic, spawning and blocking enemies. I started by creating a simple placeholder enemy sprite. Look at this beautiful arrow and tell me if you ever saw a more beautiful one down in the comment section, just below the subscribe button. After that, I created a new scene in Godot with sprite 2D, area 2D and collision shape 2D. Added a script to make it move and added a collision detection. Next, I created a new enemy spawner class, did some copy pasting from the existing ones. Maybe I have to think of some generic spawner? And for some reason, after starting the debugging process, it didn't work. I couldn't find an answer why it is not working for almost an hour. So I decided to do the best thing you can do when you can't find the reason why your code is not working as you expected. Went to bed. And you know what? The next day I found a solution in the first 20 seconds of work. I forgot to add a node with a spawner. Sometimes the most obvious answer is the most difficult to find. Now I could spawn enemies, but stumbled upon another issue. I could not make it move with the same speed as obstacles, because then it would look like another collectible to pick up for the player. So I knew I had to make it move faster to add some juice to the game. But this caused another problem. I had to synchronize this enemy with a specific obstacle, because otherwise it would just fly somewhere and the player wouldn't have to act in any way. So I looked up for some paper and started calculating after what time do I have to launch my enemy to make him appear in the center of the obstacle that our player is avoiding right now. Adding the calculated time into the code and a success. Ain't gonna lie, those small ones feel good for a newbie like me. During testing if my enemy spawner works correctly, I found a funny bug. Because spawning enemies is set after some time of spawning the obstacle, it could happen that the player lost his game during the waiting period, and then when still looking at frozen obstacles, the new enemy appeared and just moved across the screen. Why was it happening? The issue was my code, because the moving process was dependent on the boolean game running, that all new objects had to set to true on initialization, and it was changed to false when a game over event was published. And because of that, the enemy spawned after this event always had this variable as true. How to fix that? Change the way of stopping movement on screen entirely. In Godot, you can pause the game by changing the value of the paused variable in scene tree. And even better, you can specifically choose which nodes are affected by this or not. Knowing that, I added in the main node a script that handled a player collision event and then stopped the game. The only one node not affected in my scene tree will be a HUD node, which will handle changing the scenes in the future. The next step, to finally implement blocking ability. So I started by adding area 2D nodes to player and enemy scenes, made them slightly bigger than their sprites to give some time for a reaction to the player. Then I had to figure out how to detect that those two areas are overlapping. I was thinking about two options. Handle collision in the blocking state of the player. To do this, I would have to provide the info about the blocking area to the state. Handle collision in the enemy would have to provide somehow info about player's state to the enemy. And I decided to choose the first solution. I started the implementation by adding reference to blocking area 2D to the player script and then overriding onUpdate method in blocking state. There I checked if there are any overlapping areas that are in enemy area group and their position is in front of the player to avoid triggering blocking enemies which are already behind the player. If there is such enemy, then I publish an event with its ID to let him know that was blocked. If the enemy was blocked, it means it shouldn't move towards the player, so its state's changed. This is a good moment to implement a state machine here as well. So this time it was way smaller. I added just 3 states: root, alive, and dead. In enemy state driver, I added handling an enemy blocked event and passed information to the enemy context. To have it similar as in the player scene, I moved changing the enemy position to an update method in alive state. In dead state, I added changing the enemy position to the opposite direction as a normal movement to mimic blocking. In the meantime, I noticed that I use a similar wait method in 2 different classes, so I decided to move it to a separate class. I found out that if a player blocks an enemy, it is never back in the pool. Why? Because up to this moment I was only checking the enemy's position on the x-axis. To be able to correctly use the pool, I created another condition to check position on y-axis and published a proper event. That's all I have for you guys in this second devlog. I hope you liked it, and if you don't want to miss the next one, click the subscribe button. See ya!